It's hard to destroy.
Using an ion microprobe, Moisish then analyzed the zircons and measured the composition of the oxygen inside them. He found that the crystals had formed from a particular type of rock, one that could only have existed if there was water on Earth.
What was startling, exciting, fun was that the zircon showed not only that things on the Earth's surface had stabilized to within normal conditions, but that water was present, and water was present everywhere.
Moisish estimated the time the Earth acquired its water from the age of the zircons.
The zircons in some of the rocks there are very close to 4.4 billion years old.
This evidence suggests that the Earth's water arrived in less than 150 million years. On our clock, on which 12 hours represents the whole history of the Earth, that's just 25 minutes after the planet began to form. At this time, our Earth would certainly have looked very different. The sea was full of iron, much of it brought up from below by hydrothermal vents, and the atmosphere was a lot thicker than it is today.
An ocean rich in iron would have appeared green. A denser atmosphere would have given a reddish tinge to the sky.
Conditions for human existence are looking better. The land has now cooled to a tolerable temperature, and there is water to sustain life. But there is still one horrendous problem. The gases in the atmosphere are mainly nitrogen, carbon dioxide, and methane. There's not a lungful of oxygen in sight. Without oxygen to breathe, there's no way a human could survive. In the early years of its life, the Earth experienced a violent and tempestuous onslaught. In time, the activity slowed until 500 million years after it began to form, the Earth had cooled and was covered in oceans. But there was still no oxygen in the atmosphere. Without that, animals and humans could not exist. One scientist who has investigated how the Earth acquired its oxygen is geologist Martin van Kranendonk. His research has brought him to Shark Bay on the west coast of Australia. It's a World Heritage Site, home to vast meadows of seagrass, dugongs, and tame dolphins. But van Kranendonk has come to visit much older living things. This is one of only 2 places in the world where these strange living structures, called stromatolites, are known to exist.
These stromatolites have been growing here since the end of the last ice age, about 10,000 years ago. And at that time, the sea level was a little bit higher. And so these structures grew up to the present height that you see them.
Stromatolites are primitive structures. Here they come in 2 forms: short pillars of living bacteria and silt, and flat bacterial mats. The living part of the stromatolite is made up of blue-green bacteria that grow using photosynthesis. They take energy from the sun and convert carbon dioxide into oxygen.
It's really the result of this process of giving off oxygen that we have planet Earth as we know it today, and habitats that people like us, humans, and all the other animals and plants are able to live on planet Earth.
What makes Van Kranendonk believe that stromatolites created the Earth's oxygen is a remarkable discovery 1,000 miles away in a remote region of North Australia. This is the Pilbara, one of the oldest landscapes in the world. If you want to find out what happened early in the Earth's history, this is the place to come.
It's really like you're transported back into a time machine of early Earth. It just sort of gave me goosebumps and shivers to walk over this ancient environment where you could still see the processes that happened 3.5 billion years ago.
Here, at a location kept secret to preserve them, lie the oldest fossils ever discovered. The ancestors of the stromatolites in Shark Bay.
What's remarkable about this outcrop in the Pilbara is that it contains the oldest evidence for life on Earth. We're looking at here in front of me our great-great-great-great-great-great-great-grandfathers and grandmothers.
No one knows how life on Earth began, but these amazing fossils suggest that it emerged very soon after the planet formed. These fossil stromatolites are 15 times older than the dinosaurs. The bacteria that made them were living here just 1 billion years after the birth of the Earth. On our 12-hour clock, the time is now 20 minutes to 3.
These would have been the first organisms that would have started the process of change of Earth's atmosphere to an oxygen-rich atmosphere, which has allowed us, mankind, and all the rest of life that we know today to evolve on planet Earth.
If stromatolites existed on the Earth 3.5 billion years ago, they should have started to increase the amount of oxygen in the air. But it appears that they didn't. For the next billion years, the oxygen level in the atmosphere hardly changed. What happened to all the oxygen the stromatolites produced can be seen 300 miles away in this gorge in Australia's Karijini National Park. Hidden in these rocks lies the key to the mystery of the missing oxygen. Geologists call these rocks banded iron formations, and they believe that they owe their existence to stromatolites.
Well, these banded iron formations are the product of a remarkable set of circumstances in Earth history. They formed about 2.5 billion years ago when the Earth was very young, and are the product, we think now, of microbial action in the ancient oceans.
The Earth's early oceans were full of iron. As the bacteria in stromatolites bubbled out oxygen, it reacted with the iron in the water. You can see what happened in this simple experiment. This flask of water contains iron. It's the same color as the early oceans on Earth. This pump does the work of a stromatolite pumping out oxygen. As the oxygen bubbles through the water, it reacts with the iron to form iron oxide, and it precipitates out as rust. There was so much iron in the oceans that for over 1 billion years, it absorbed nearly all the oxygen that the stromatolites produced. As the rust precipitated out, it fell to the bottom of the ocean and was turned into rock. It has been estimated that around the world, these rocks have locked inside them more than 20 times the amount of oxygen that is in the atmosphere today. And they took an incredibly long time to form. On our clock, in which the whole history of the Earth is represented as 12 hours, we can see that the planet forms in the first 8 minutes. After 25 minutes, it has cooled and collected water on its surface. But it takes another 4.5 hours to remove most of the iron from the oceans and deposit it in these rocks. Only then does the oxygen level in the atmosphere start to increase. This happened approximately 2.5 billion years ago. And for the next 2 billion years, the level rose. Until just 500 million years ago, it reached the level at which animals could survive. So is our planet finally fit for human life? By this time, it has certainly cooled. There is water to drink and air to breathe. If we could travel back to this time, we could certainly survive. In our story, 11 hours have now passed. But the Earth still has a long way to go before the first humans will walk on its surface. At 37 minutes to midnight, dinosaurs will emerge. At 10 minutes to midnight, they will be wiped out by a catastrophe. Finally, at 19 seconds to midnight, the first humans will appear. It has taken over 4 billion years. But out of a vast region of freezing dust and gas, the forces of nature have created the only safe haven we have in the universe. Our home, the Earth.